Since the dawn of time, man has had graphic systems at Ford Motor Company, CADs and PDGS. CADs is used to develop powertrain systems. PDGS is used in all other activities. The name are no commands to remember, and the user needs no prior computer experience to learn PDGS. This designer is working on a fender that are using the CAD data as the only source of data on the part. Drawings or physical models, if produced, are used for reference only. Released parts are stored on computers like the escort part from a data collector in Hiroshima, Japan. With these menu picks, we'll tell PDGS which part we want. The remote data collector could take weeks with paper and models. Our part is listed on the local data collector. Now we can bring the part to our local disk to work on. We can work from this part or make suggestions and send the part back and the errors introduced by manual methods have been eliminated. This screen shows how the numerical control program plots cutter paths. NC data is directly transferred to a cutting machine. On this machine, NC data even controls meat. This coordinate measure machine, or CMM, is using the path developed by fins to check our die. The fins data was transferred directly to the CMM. FIN supports a myriad of coordinate measurement machines to check prototype check parts, eliminating the need for drawings and most of the harness models for checking designs. The EDGS data is used not only to design wiring harnesses, but also to chart the circuits and check for continuity and component compatibility. The EDGS data provides a bill of materials, which is used for prototypes. The models are built, the data is processed, and the kinematics models are set into motion. These images show some of the activities which use kinematics models. By using new component technologies can be more readily incorporated into our vehicles by electronically substituting different components in the systems and evaluating the results of the analyses. Instead of the few iterations that manual method. Instead of going through the time-consuming and costly process of building many prototype parts, the prototypes built with the benefits of these analyses are very close to production parts and systems. This video is a very brief look at some of the CAD/CAM tools available today. Our in-house development teams work closely with our users to design and produce the enhancements they need to do a better job.
The core tool used in all this is PDGS, and that's kind of what you're seeing up on the screen here. This is a rear projection of actually coming from this computer over here. PDGS itself maintains all these other packages that we support here that you kind of saw on the videotape. What I'd like to do is take a moment to discuss PDGS in particular. Let's turn this off here. To take you back to the beginning, this is how it really all started. PDGS itself is the tool that we support here, but in the beginning, what we had was people doing the work manually on a drafting board. Now this is going way back to my grandparents' period, probably your great-grandparents' period. And for years, this is how Ford Motor Company did business. People manually drew parts of the automobile. As the years went by, this is a shot of around the mid-60s. You can see the tools that this fellow is using here. Triangles, compass, you know, all by hand, which this process was very tedious and time-consuming. So as the years roll by, you have a similar shot. You know, this is years later and we're still doing the same thing. Well, with the advent of computer technology, all this process is changing quite rapidly now in the current days. What you see here is one of our first versions of PDGS. This was on a Lundy computer, which is an ancestor of this job right here. The difference between this and the past is when these folks drew their parts, they had 3 dimensions to work with. It wasn't just a flat sheet of paper. They could actually identify depth, as you may have seen in the video, which we'll do in a moment. Now, one of the drawbacks of this system is that the data had to be carried from system to system via magnetic tape. So in essence, this is the sheet of paper that we had. So you still had to deal with manual communications here. This is just another shot of the of that computer, fellow working on that computer. As the years roll by, these Lundys here are the same ones that we have here. This system came along and we had developed what we call a storage area called a data collector. The thing about that is, and we could do that in this room, is we have access to every Ford site all over the world. So that's the difference as PDGS progressed. This is just a map of the sites that we have. As a matter of fact, there's a friend of mine that lives in Brazil. I can talk to him, send him mail just via the computer. I can log into his area and pull data from Brazil or any part of the world, actually. So we have direct access to Ford sites. We don't have to worry about, communication types. We can get this data immediately. And this is pretty much what it looks like today. Next door in the other building, this is where this shot was taken from. Although, however, things have changed even since this photograph was taken. We were moving from what we call the Lundy tube or workstation to a Unix environment. The reason for that is these other workstations here, this is what we call the Unix workstation. The difference between that and, say, the Lundy tube is the Lundy, that machine over there was built specifically to support PDGS. But as we're going along through the years, there are many other computer applications, and of course there's cost that's involved as well. With these computers, we can support other computer software in addition to PDGS, and folks that support Ford Motor Company outside of Ford can buy these machines, run PDGS itself and other computer software. So it's cost effective. This is still, after all these years working on the computer, we generate manual drawings, but what we're working towards now is something that we call CAD-CAM the master, whereas our goal is to get away from paper, create a paperless community here where all your data is stored on the computer. This is the master. PDGS is the master source. We won't deal with the paperwork and checking just like we have in the past. To this concept in the future, whereas we can build cars on the screen, color shade them, and develop all our concepts electronically and on the computer system. This is just a shot of some futuristic ideas here that we have. But it's all cost saving. If you can do it on a computer, you don't have to worry about building models. Yes?
Are those clay models?
These aren't in themselves. These themselves are just a pictorial that was developed on a system. Actually, it was another system called Colossal. And we color shaded it and rendered it in color, and this is all computer generated itself. We still do clay models within Ford Motor Company, and the idea is to move away from that type of time-consuming process and work towards doing all the work on the computer itself. It's what we call CAD-CAM the master. And once again, how we use PDGS in general, as you can kind of see, this is our work area, or this is the design area of the screen. These menus that you see on the screen, this is generally what we call our design menu, and it's what we call a menu or tree structure, which means that if I make a selection from the screen, you see the entire menu changes. So you have a completely new list of commands to select from. Everything you select takes you to a different menu, but there's always an escape hatch out, and the key to all this is down at the bottom here. In this case, it's a return. There's either a return, proceed, accept, but there's always an escape route out of this tree structure. So when we design on PDGS, we use this menu or selections from this side of the screen generally to build line data. We have several different entities or pieces of geometry within PDGS. What you see on the screen is manipulated by this set of menus down below. So even though you have all this stuff you're seeing on the screen, you can break it down into some generalities, because how you want to see what you're working with is down below. How you build what you are working with is over on this side. And of course, this is just your display area. Let's see what time we've got here. Now, what I'm going to do is just move from, say, what we're seeing here, inside a part that has just all kinds of data, just to illustrate the fact that we're working within a three-dimensional environment. What we have here is a 1989 Thunderbird. And again, to manipulate how we're looking at this picture, as we call it, what you're really looking at is a series of lines put together to illustrate this Thunderbird. If we make a selection, we can rotate, as what we call dynamically rotate. And what you're dealing with is actually a three-dimensional cube area. For example, we have space coming out towards you. We have some space going into the screen. It's literally a cube area. And we can build lines in front of lines to give this illustration of a three-dimensional environment. Again, you might notice that I'm selecting from the very bottom of the screen here. This is just how I manipulate what it is I'm looking at. We can kind of zoom in on a particular area or move on out. What we call pan across the screen. So you see I'm starting to go outside my area. Actually, what's happening here is we're the ones that are moving about. This data, what we have is we have a set of standards, and all this data is to be built at a certain position in space. Now, how we figure out where we are in space, you might have noticed a second ago, is by this grid pattern. And there's a series of numbers at the top of the screen and along the side, but it's just like a graph is what it is, except it's three-dimensional. Here it looks two-dimensional, but remember we have depth coming out towards us and going into the screen as well. So this is how we figure out where we're going. Normally we'll start at an area of, say, 0, 0, just like on a graph, and I can just barely see, here's the 0 line here, and here's the 0 line here, and it's from this point we can figure out where in the world we're plotting this data. Just to show you a little bit more about what this data is, it's selectable, for example. We can use this little tool we call a mouse here because it's got a little tail on it. And literally select a piece of data on the screen, and you may notice that what you're seeing here is just a piece of that automobile lit up. All these little symbols on here we call points that make up the structure of the line itself. And we can manipulate these points, and where we place these points is how we manipulate the shape of that line. Now, another piece of geometry that we have within PDGS is surface geometry. Let's hold on just a second here. Now, the difference between a surface and a line, so to speak, is that we can identify area covering a structure, like this tabletop, for example. Not just that we could draw just like what we call wireframe construction. We can actually identify the area or the flat spot of this table by developing what we call a surface within PDGS. Now, what you're looking at looks like lines to me. However, we can select this data and throw what we call a mesh around it so you get an idea of what the shape is, the cylindrical shape of the surface data. Now, we've actually moved on beyond this. We can actually color shade these surfaces. I'll do that in a moment. But just to give you an idea of the area that we're working within, say we wanted to plot an intersection between those two surfaces. There's a command here called add intersections, and all we have to do is just select one of these surfaces and the other, and immediately you have a line generated. See all those points? That's lying right on where the two areas of the surface, those two surfaces intersect. Okay, sure, sure. Okay, great, terrific. Now what you're seeing here is those same two surfaces, only they're developed a little bit differently. It's a new type of entity that we're working within PDGS, but the thing that's cool about this is that we can color shade it and you get a much better idea of what that surface looks like as opposed to that mesh that you saw a little bit ago. Let me actually go in here and let's change the color of this. Get it yet. There you go. This will work a little better. There you go. So you can see that a little bit better. You have all these kind of mod colors you can work with. But the idea is that this is a tool that we can use to better illustrate the shapes that we're dealing with. And this is the way computer technology is progressing. And at Ford Motor Company, we're trying to keep up with that progression. Maybe something that looks a little bit better here. Now here's something, believe it or not, what this is it's just a little car radio button that you push to just change the channels on your radio. Now at this point, it doesn't look like, it's kind of hard to get a hold of it because it's what we call a wireframe appearance. But with the shading, we can color shade that, and it just looks a lot more easier to understand what these shapes are. Let's see what we got here elsewhere I can look at. Well, just to quickly show you something about some of the things that we can develop within PDGS, and what we'll do maybe is have you guys work a little bit on the system yourself. What we have here is just a series of lines. It's an axle. We can develop a tire, what looks like a tire, or tire envelope as we call it, by going through a few simple commands. For example, we go into this command. You can maybe barely see it says swing, because literally we're going to swing this piece of data around an axis. First of all, the axis is right here, and I still have to identify it by selecting a couple of points, so we have just a straight line identified. And then what the menu is asking me to do is select what it is that I want to literally swing around that axis. Remember, we're working with this within 3 dimensions. Also, as I do this, the menu says define flow lines. Now you notice I'm jumping all around on the screen, but as we always try to tell our folks that are learning PDGS, all you have to do is really just read the menus. What it means when it says define flow lines is identify lines that will follow the flow of the swing. Well, let's see. For example, let me just say all data points, which means all those little points that are lit up on that line. Then it's simply asking me, where would you like this line to begin, and where would you like it to end? And I simply want to go all the way around. So I want to start right where I'm at, which is at a so-called angle of 0, for example, and I want to end 360 degrees from that point. Now actually I was using this tool up here. I can't specify 360, so I'll jump over to this tool over here and just type it in myself. And what I want to do is also reiterate this at an angle increment of, say, every 10 degrees. But at any rate, immediately you have more data generated from data that already existed. And that's one of the nice things about CAD/CAM, is you can build data from other data that already exists. It does it for you. You just give it some of the few parameters that it needs. And again, we can go in and kind of rotate. This is kind of getting so fast, it's getting out of hand for me. But again, what's happening here is we're literally the ones that are spinning around this piece of geometry. We keep the geometry stable within space. That space, again, it's defined by, you can see by this grid pattern. That's how we know where all our points are at, by those little numbers at the top of the screen and onto the left-hand side. Well, actually, at this point, I tell you what, I'd like to spend more time getting you guys on the system, and maybe we can go through a little experiment and see I can get you to actually help me with a design function here. So if you'd like to, why don't, see, we may have enough for almost maybe 2 or maybe even 1 person at each one of these workstations. Just make yourself at home, take a chair and slide it over to, say, any one of these, maybe one of these 3. We'll go around this one because we have a light here. And
Yeah. That's for him.
yeah, we'll take care of it. We'll take care of it. We'll talk you through a couple of steps.
Any personal questions though? Anything about education, experience?
What type of background?
My background, I got a bachelor's in math. I went to Southern University, Baton Rouge, Louisiana. I got a master's in math from University of Michigan. And with that, about 20 years experience here at Ford. Yeah.
You help design the car?
My career mostly was designing the software associated with the tool that you have there, CAD/CAM. And indirectly, I help design cars, but most directly, I design software. Okay, enjoy yourself. I got a meeting I got to run to, and I'll try to catch the next group when I get a chance.
Thank you.
Thank you.
Next week. They all depends on the first 15 and then the league. You'll have this full year.
Okay, everybody. If you can't
I'm sorry.
No.
I mean, no, what do you do? A drawing on paper and graph paper?
Well, at any rate,
This is
Okay, did you start the cut?
I just remember we talked a little bit about the graph, for example. What I'm interested in doing is plotting a line right across the screen, and see, I can kind of tell where I'm at by this grid pattern. Remember we mentioned the y. Just remember, think of it as a graph, and say 450, and you can just select those numbers.
Okay, click on the
There you go. Now we can call this. There you go. That's it. You guys got it. Let me see if I can help you guys now. See what you got here. Nice. Now you notice you were working with all this stuff. This is really about a lot of guys that have been working on designing for years, and they start showing them things like this. You know, like man, you know, it's a big thing. But to get yourself out of here, say select the material. You got it. Wherever. I think this is going to be my
No, this one. Okay. So what you wanted was 3,750.
Now you see, if you look at these two different ones you got here, depending on the way you pick your points, he picked one different than you did. So his line is a little bit different. But that's where the design, you're going to have to imagine what the whole panel is going to look like, and whether this is really true or whether that's not true. It's totally dependent on where your boss is going to be on. They want things to be accurate.
Okay, so are people working individually on this or as a group? Like one person will decide one certain thing and somebody else will decide?
It works both ways. We have a larger group. Just push that mouse right down and hold chassis, they do the exterior, and you let go of it, it stops. And then you look at this thing and see where your sections cut through, see how it bounds and points in each of those lines.
But you still have designers.
It just goes, this is what goes on the board. That's why we have this here, make these. Slowly, a manual input to an automatic system. Take that, digitize it into these computer systems. That's what it is.
So new designers coming in and how to be able to speak.
Oh, yeah. Either that or
Okay.
if they hire it doesn't matter whether it's a play with the mouse. Hey, John, did you have anything?
That's actually we're almost getting out of time, I think.
Is that right? I don't know what else is in this part. Go up at the top where it says PIC equals. Select that.
I thought there was one in
Not in that one in particular. There's another part called UAW.
Oh, is there? Well, let's do this. Let's go back to return again.
Originally, I was going to have them pull that one down.
And go up.
See that where it says what section it's in? Here's all basically, that's a three-dimensional wireframe set of data for what a dynamic rotating.
What you told him to do was to move the point and follow what we call tracking.
A whole bunch of the